Hello everyone, here I am going to explain program 3 of microcontroller and embedded systems lab. The question is write a program to find a factorial of a number. Here I am going to consider the number 4. For 4 I am going to find the factorial. 4 factorial is equal to 4 into 3 into 2 into 1. So there is going to be 3 multiplication. So when we multiply all these, we will get 24 decimal value. So 24 decimal value should be converted to hexa because in the assembly code we are using hexa values only. So when we convert 24 decimal to hexa, we will get 18H. For this concept, we have to write the assembly instructions. We'll see the program. First instruction, first area we have to write. After the area, session name should be written, followed by memory. Here the memory is code memory because all the instructions will be stored in code memory only. Code memory is read only memory. Next instruction, next is entry point. This is entry point to the program. The first instruction move R0 comma 4. Here the 4 is considered as count. The count is moved to R0 register. Then the same R0 value is moved to R1 register. Next instruction we are reducing the count. Subtract instruction. So this instruction gives R1 is equal to R1 minus 1. So here 4 minus 1, 3. So first time R1 becomes 3. Now I am comparing the R1 content. R1 content is 3, 3 with 1. So the first time 3 and 1 I am comparing. Next I am multiplying R0 and R1. R0, R1 are multiplied. R0 is 4, R1 is 3. So 4 into 3 are multiplied and the result is stored in R3 register. Then the same R3 register, R3 content moves to R0. So here R0 value becomes 12. Next I am checking the condition branch. This is branch instruction, conditional branch. Branch, when I have to jump to fact means when I have to check the compare instruction. In compare I compared 3 and 1. If both are not equal, I can jump to fact. Here both are not equal, condition is true, so I can jump to factorial. Fact. In this loop again I have subtract instruction. So this time 1 is subtracted from 3, so R1 becomes 2. So next comparison will be between 2 and 1. So next I am multiplying R0. R0 is 12. 12 and R1. R1 is 2. So this time I am multiplying 12 and 2. Answer is 24. That is available with R3 register. That R3 moves to R0. Now R0 is 24. Now I am checking the condition. In the compare instruction I compared 2 and 1 whether both are equal or not. Both are not equal, so that I can jump to fact again. So again I will subtract 1 from 2 this time. So R1 becomes 1. I am comparing 1 comma 1. I am multiplying R0. R0 value was 24. R1 is 1. So 24 into 1, 24. It's stored in R3 register that moved to R0. Now R0 content is 24. Now I am checking the condition. In compare instruction I compared 1 and 1. Both are equal, so the condition becomes false. So I cannot jump to factorial. I should move to the next instruction. Next instruction is terminating the program. So the result final answer is 24. 24 is available with R3 register as well as R0 register. So this is the explanation. Now we can see the execution using Kale software. Okay, now I open the Kale window. The first step is project, new microvision project. The desktop, I am creating a folder called fact. Inside the folder, I am giving file name fact. Next vendor, vendor is NXP. We have to choose the NXP. Our ROM is LPC2148. Okay, yes. After that, file, new. So this is project window, this is editor window. Here you have to type your program. I am pasting the program. So after typing the program, I can save it. File, save. So this is my file name. I am saving with extension .asm because our program is assembly language program. Save. After saving it, we have to move our file into the target. So click on this plus, right click on the source group, add existing files to source group. So my file is fact with the .asm and the file type is not C source. Our file type is assembly source. Okay, I added the fact into the source group and I deleted the starter file. So after doing all this, I can save it and project build target. I'm building the program for the error checking. Now I got 0 errors and 0 warnings. Now I can go for the debugging. So debugging, okay. So this is our program. These are the registers available in user system mode. All the registers are 0 now. Now we'll start executing the program. So now you can see the arrow is here, means the program counter. Program counter is here pointing here. First instruction is going to execute it. Execute is move R0 comma 4. So we will execute the program step by step. So we'll click on this. So in the first instruction, 4 move to R0 register, R0 content change to 4. Next instruction, R0 content moves to R1 register, so R1 becomes 4 now. R1 became 4 here. Now subtract, I am subtracting 1 from R1. So R1 is 4, 4 minus 1, it will become 3. So R1 become 3 now. So it became 3. Now I am comparing 3 comma 1. So compare instruction will not be stored anywhere. So no changes will be there in register content. Only the PC value will change. So PC value next time you can see it is 10. So previously it was C. Now it became 10. But comparison result it's not stored anywhere. Now I am multiplying. First time I will multiply 4 into 3. So that result we can see in R3 register. So R3 register is 0 now. For the next click it became C. Because when we multiply 4 into 3 it will become 12, 12 decimal number. For that corresponding hexadecimal value is C. So C you can see here. Now I am moving this to R0. So R0 will become C. So one by one you can see everything here. For the last output, for we know that the result is 18. That result will be available with R3 register and R0 register. See, you can see here R3 became 18 and R0 is also became 18. So this is our result. R1 content. Previously it was okay 2. So see, you can see here R1 is 2 now, because the in the last loop R1 will become 1. R1 will become 1, but that will not be stored anywhere. So the result is 1. See. Okay, see students, in the program we used 3 registers R1, R3 and R0. So all the 3 content you can check here. We know that R3 and R0 are 18. You can see R3 and R0 are 18 and R1 is last time it will become 1. So last the 1 is in R1 register. So all the 3 register content you can check in register set. So this is the output for this program. Thank you.